like to go back for a moment to a point you raised earlier, and that you mentioned you're concerned about mooring systems supply chain bottlenecks. Why?
I try and summarize it in 3 words: quantity, flexibility, size, or component size. So that's 4 words. So quantity, we're forecasting a ramp up of commercial wind farm numbers towards the end of the decade. We're at demonstration pre-commercial scale now, and the ones that are going in the water now are sort of 3-4 turbines. By the end of the decade, we'll be sort of seeing 30, 40, 50 turbine arrays. So, significantly bigger. Now, let's take an example of a typical commercial floating wind farm of 500 megawatts. And we do actually see quite a few 1,000-megawatt projects out there. Now, a 500 megawatt project, what does that translate to? That's over 34 turbines, or around 34 turbines, let's say, just assuming you go with the biggest commercially available turbines today. That's 34 turbines. That means 34 floating systems on which the turbines sit and 34 mooring systems. Now, that translates to actually to over 100 anchors and mooring lines. Now, that doesn't actually sound a lot, but when you aggregate that across 4, 5, 6 wind farms that need those numbers, you start talking to be quite a lot of mooring equipment. But then if you compare that to something like a floating production system, which has pre-laid moorings, anchors and moorings, I mean, that might have, 16, 24 mooring lines. Here we're talking 100 anchors and mooring lines. So we're talking an order of magnitude bigger. Some of them may be a bit shorter, but when you look at the actual volumes, the volumes start to get a lot bigger. And that drives vessel capacity, because your vessel capacity is generally built for floating production systems and drilling rigs. What you're asking them then to do is do bigger quantities of it. So when you've got a tight market in the oil and gas side, what that indicates there may not be the supply for the additional floating wind projects when you get to commercial. And that is a point, that there is that the floating wind projects will be competing with a buoyant oil and gas segment for the same equipment that installs vessels, which is really anchor handlers and subsea construction vessels, or subsea construction support vessels. Now, on the flexibility side, you've got well over 80 different concepts of how to sit a turbine on a foundation. So 80 or 90 floating structures. Now, they loosely are grouped into semi-subs, spars, TLPs, loosely grouped into that. But they're all a bit different. Some are box-shaped, some are cylindrical, some are made from tower and monopile components, some are concrete, some are steel. So, I mean, there's a lot of differences. And the people designing them have different views on the mooring systems, how they're tethered to the seabed. Also, ground conditions play a role, which mean that solutions are going to be different. So as a supplier, what you need is the flexibility to accommodate multiple needs. We do see that there are going to be some systems that are currently, in the short to midterm, more preferred. Well, the semi-sub, for instance, we see is more preferred, and these systems will generally be moored, we think, by conventional mooring spreads, although some systems will be single-point mooring or tendon mooring systems. But they're going to feature steel chain, spiral wire, and or fiber rope, a combination of all three or just one, connected to a variety of different anchors, from drag embedment to suction anchors to piles. There's no one fixed solution. It's all ground conditions related, although, again, we see drag embedment in certain markets certainly being the preferred solution in the short to midterm. Now, flexibility is required to meet the various requirements. Otherwise, you might have the installation equipment that's good for one specific environment, but not for everything. And again, the flexibility around that is very important, but understanding the nuances of how that flexibility is met. Aside from the components, this one, what I've said is we've taken a deep dive into a lot of planning documents for projects to see what developers are actually planning, what they're asking permission for. Doesn't mean they're saying we are going to do this, but they're saying we are considering these options. And when you look at these, the flexibility of solutions that deploy chain, wire, and rope sizes that are amongst the largest currently available, manufactured, I mean. And these are larger than those deployed for station keeping in the oil and gas projects, and in some cases much larger. we have a case then that the vessels which were designed to accommodate the oil and gas projects and are optimal for those become suboptimal for the floating wind projects because they may not simply have the capacity designed for that. So to try to bring an end to this long story of the detail, if you bring all those factors together, which we do in the report, against the vessel supply category that's there, because we rank and each of the large anchor handlers and subsea construction support vessels, we note that most of these vessels lack one or more of the key attributes that makes them optimal for floating wind. It doesn't mean they're not good for floating wind. They can't be used. What it means is you just need more of them because they lack the full flexibility to do everything. That means instead of one vessel, you need two vessels to do the job of one. And when you've got high utilization in the market, that basically means you're putting a strain on the market supply. And that's where we see the problem, because we see oil and gas demand quite high. Now, so that just leaves a vessel owner with three choices. And this really is what it boils down to. You either deploy these existing vessels on floating wind and oil and gas projects, and our view is that there won't be enough vessel capacity for project schedules to be accommodated. So if you want to build these projects, it just means you need more vessels. If that is your solution, to use what you've got already, we won't have enough. It's just absolutely not. You can upgrade existing vessels to accommodate the needs of floating wind. And this is technically possible. And some vessel owners and equipment makers have studied the requirements. So it is technically feasible. But if you do that and you're spending money on your vessel, you're still probably then taking away one feature or two features that makes them optimal. So you're solving one of the problems, but maybe not all of the problems, which may make them project suitable, but maybe not market suitable long term. So then you've got to question long-term investment and the risk profile around that. And then just ultimately, as I said, if you're saying that, well, we can't just deploy what we've got and we can't upgrade, or we can do that, but even if we deploy what we got and we upgrade what we got, we're not going to have enough. The equation that comes out of that is we need more vessels built.